Welcome everyone to New South Wales DPI Dairy webinar number 22, AMS Integrated Management Model, a decision support system for planning and optimizing AMS. As I mentioned before, my name is Nicholas Lyons. I'm the lead at Dairy with New South Wales DPI, and I'll be your host today. But I would like to introduce our guest speaker today, Mr. Juan Gargiulo. Juan Gargiulo is originally from Argentina. He's got a Bachelor of Science in Agriculture. He's just recently submitted his PhD at the University of Sydney, and that's the picture of submission while in lockdown, so not quite fun and responsive as he was expecting it probably. But yeah, 3 years and a bit came to an end, and he's happy obviously about it, and he did a great job. He's been closely involved with the Milking Edge team. Milking Edge is an industry-funded project by Dairy Australia, New South Wales DPI, and De Laval, supporting the successful adoption of robotic milking in Australia. So he did his project closely kind of aligned with what we were doing in the project. He also started with working with us as a development officer dairy with New South Wales DPI. So it's exciting to have him on board the team now. And Juan is highly experienced in dairy production, remote monitoring of pasture, farm business management, and data analysis. So Juan, it's a real pleasure to have you with us here today. And I'll share presentation rights with you so you can share your screen with the audience.
Thank you, Nico, for the introduction. Can you see the screen properly there?
Yes, perfectly fine.
Perfect. Thanks, Nico, for the introduction, and thanks everyone for joining today. So I will talk about the AMS IMM, a decision support system for automatic milking systems that we developed as part of the Milking Edge project and as part of my PhD. So I would like to start with the definition of a decision support system. And a decision support system is a computer-based system that helps people use data, models, documents, or knowledge to solve problems and make decisions. So there are different types of decision support systems, are categorized based on the source of information primarily. For example, there are data-driven decision support systems that, for example, are systems that summarize and help to collate or analyze large databases. There are other decision support systems that are model-driven, that are based on financial models or optimization models and are mainly based on those type of models. Others like document that help to retrieve or store documents and retrieve information for those documents, and other types like hybrid that are mixed of some of them. Some of the advantages of decision support systems is that allows users to explore a lot of alternatives in an easy way and with almost no cost involved. It helps to improve decisions of improve decision making and also understanding of the processes and the business in general. Also allows to improve the communication because allows to summarize, for example, a lot of data and present it in a proper way. So improve the communication within the organization and save time and provide a better use of those resources and data. So why we develop a decision support system for automatic milking systems? And first, we realized that adoption rates of pasture-based AMS was lower than expected, for example, in comparison to confinement systems. So as part of the Milking Edge project, the main aim was to maximize the adoption of pasture-based AMS and also support a successful transition to AMS. So we thought that one way was to develop tools or information tools for farmers that were willing or were thinking in adopting AMS to analyze better the suitability of these systems, and also to help current farmers, robotic farmers, to improve efficiency and make the system more efficient. So with the decision support system that we developed, basically what farmers or users can do is simulate physical and economic scenarios, simulate optimization simulations, and also benchmarking, allows benchmarking. So basically this tool was thought for farmers considering AMS, as I mentioned, first in general to assess and plan the investment better, and also to develop realistic expectations of what they can achieve with AMS, and finally to improve understanding of AMS. But also we thought about this tool, or this tool is also useful for farmers operating AMS currently, because it helps them to identify some areas of underperformance and also optimize their current performance. So it shows the user how to go from a situation A to a situation B. So the key components of this tool, this tool is basically a hybrid. It's a mixture of a data-driven decision support system and a model-driven decision support system. Basically, the main component is the AMS farm data that we collected throughout this project, some models that we developed, and a user interface that we developed also, a web-based user interface. So the data is one of the key components, as I mentioned. We use two different data sets. The first one is a data set collected from 18 Australian AMS farms across all dairy regions from the country. We collected this data during 5 years. It's annual data and annual economic and physical data, and we collected using the Dairy-Base methodology. Dairy-Base is a website, a website that allows users or farmers and consultants to compare performance and input different data, historical data from the farms. So if you want to know more about this data set, we also published last year a comparison using this AMS data with conventional data from the Dairy Farm Monitor project, and we published it in the Journal of Dairy Science. If you want to know more about this economic data set, you can access to check out this paper. The other data that we use for this tool is on the AMS KPI project. That is a benchmarking project where we are monitoring physical performance of robotic farms across multiple countries. So the tool used data from 28 international AMS farms from Australia, Ireland, New Zealand, Chile, and Argentina. We collected data from 5 years. It's more a robot and system physical data. And basically what farmers get, participant farms get from this project, they receive on a monthly basis a report with a benchmarking report, and also we produce individual reports where they can understand more how they are performing in comparison to other farms and identify potential areas of improvement. So we use all this information that we collected during many years and developed the model that sits behind the tool. But basically what we did was, first, we identify the main factors affecting profitability and productivity in AMS. using all this data set. And we developed some predictive equations based on all this data. For example, that predicts based on some inputs, some outputs like profitability, for example. After we define those equations and identify those main factors, what we did was we defined input parameters for those equations. So instead of using single values for the equations, we use distributions that we define based on the real data that we collected. And also we established some correlations between some of those input parameters. For example, correlation means the relation or the association between the variables. For example, if you increase cows per robot, you tend to reduce the milking frequency. So there's a negative correlation there. So we put in a model those distribution and those correlations, and then we run some Monte Carlo simulations that are the base of this tool. But basically, these simulations use, as I mentioned, instead of single values, use distributions, correlations, and also random numbers to simulate scenarios. And then after the simulation, we summarize those outputs and show the data as an average, or you can show it as the mean, as an average. In this case, we show the data as the average. Then, after collecting the data, developing those models, we developed a web-based user interface that I will show you in some minutes. But yeah, basically, it's a website that the user can access and play with this, with the figures and numbers, and it looks like this. And then what we did also was to evaluate how the tool performed. So we used data also from 21 AMS farms from all these projects, 2 years of data, and we tested how those predictions and models were working, and we found that there was a good accuracy in those predictions. Finally, after all this development, we tested this concept with some farmers. So what we did was we developed a tutorial video and some tutorial material guides we sent to farmers and explained how the tool worked. We sent this to 11 farmers from different countries, and then we sent them a survey to see what were the thoughts about how useful was the tool and how easy to use was. And overall, respondents said that this tool was useful, 4 out of 5 stars, or in a ranking of 4 out of 5, and they perceived the tool also easy to use. And we launched this tool officially last month, and around 70 users already use this tool from several countries, sorry, and primarily young people around 25 to 34 years. So the tool is freely available at this website. You can access this tool, and if you have any questions, we can discuss it now, or if not, I can go ahead and show how the tool works.
Maybe, I don't know if there's any burning question, we can tackle it now. Otherwise, maybe Juan, it's better for you to show the tool and we can tackle kind of the questions at the end. There's no question that has come through as of yet, but
Perfect. So the tool looks like this. It's a website, as I mentioned. And first, you have different tabs here that you can access by clicking on this tab, and then shows a main screen here. But basically, here what we did was we developed tutorial video and a guide that describes really in detail how to use this tool. You can check this out later if you want. Basically, it has, or one of the key features of the tool is these gauges. So these gauges, what they show are here a value that is a simulated value or the value that you input here. And then what it shows here is the minimum and maximum values obtained from commercial AMS from the database that we collected. And the color here in the gauge shows how likely is to achieve this value in the middle. So for example, in this case, it shows the milk harvested per robot. So it shows that achieving 1,800 kilos of milk per robot per day is in green color. That means that only 25% of the AMS farms in the population, in the data that we collected, are achieving 1,800 kilos or more. So this is one of the key things of the tool, these gauges. Also, you have different buttons throughout the tool that you can manipulate or change. For example, you have this type of sliders that you can set upper and lower limits and change things. Or you have this type of buttons that you can input a number here. So most of the features in the tool are interactive. So for example, if you hover the mouse over this button, it will show you a description of what that button does or what's the meaning of that variable. So the first tab here, it's called the AMS benchmarking tab, and we thought on this tab more for farmers that are operating AMS, because it allows you to quickly identify some areas of how you are performing in comparison to other farms. For example, here what you have to do is enter, or you have different indicators, the main indicators of the system, and you have to enter here your value. And for example, we have milk harvested here. You can enter 1,500 kilos of milk harvested. So in this case, the color changed to green, which means that 1,500 is only achieved by the top 25%. You can change here, for example, to 700, and it will show that only bottom 25% achieved 700 kilos of milk harvested. So this tab is not connected with the rest of the tool. It's just to identify how you are performing in comparison to the database. So you can do the same with other indicators, financial indicators or other physical indicators. Then you have this first tab, that is the overview tab, and it shows an overview of the model, of the main indicators of the model. But basically, to start with the simulations, you have here 4 numeric inputs: the number of robots, the number of cows in milk, the daily milk yield, and the total labor. So you need to input these 4 numeric inputs to start with the simulations. So for example, in this case, the default values are the average of the population, the average of our dataset. And for example, here we have a farm with 3 robots and 166 cows, 22 liters per cow per day, and 1.6 full-time equivalent. So for example, if you change here from 166 cows to 100 cows, you will see there that the operating profit margin will go to 0, will be almost 0. The milk harvested per robot will be reduced, cows per robot, of course, and the expected milking frequency will be 2.3 milkings per cow per day. If you increase this to 200, you will see here that operating profit margin goes up. Well, and of course, cost per robot goes up, milk harvested, and the milking frequency goes slightly down because there are more cows in the system. So this is the first, an overview of the main indicators. You need to just enter 4 main inputs that are based on our research and are the ones that have more impact on the system. Then if you go to the following tab, you have this called the system performance tab. You have more detailed indicators of the robot and are more physical indicators in general. So you have here things like milkings per robot per day, or milking time, the time that the robot is operating per day. So based on these 4 indicators, you have here an expected milking frequency. But for example, if you are a current AMS farmer and you are not milking 2.1 milkings per day, and you are milking, let's say, or your target is less than 2, you can set this according to your own situation. For example, you can say, I don't want to milk more than 2.5 milkings per cow per day. You can limit there. Or you can say, in my case, I'm milking 2 on average. So you can set 2 milkings per day. So in this case, you can adjust your own milking frequency here. So then in the next tab is the economic
Sorry,
tab.
Juan, I'll jump in there just to clarify that point too. The good thing of that is that there are some variables like changing the milking frequency won't change the yield per cow or the yield per box, because that is kind of simple 101 maths. But by changing the milking frequency, you start seeing the impact on kind of the milk per milking, the time that the robot operates, and you can start seeing the impact on other variables, because it's all, these variables are, yes, all connected through the model.
Yeah, that's right.
Perfect. There was also one question come through, and I'll tackle it now just because I think it's more appropriate. Can you tell us why do you have those 4 variables on the left, and also what is the values that appear by default in each graph or box?
Why we have these 4 here? So that,
yeah.
that
So
was
why robots, cows and milk, days, daily milk yield, and total labor?
Yeah. So as I mentioned in the presentation where I was talking about the model development, what we first did was identify the main variables having impact first on profitability. And what we found in that research, so we put all the data together in a regression model and tried to identify which were the variables that have more impact. What we identified there was that milk harvested per robot and total labor in full-time equivalent were the 2 factors that explain most of the variation in profitability, in return on total assets and in operating profit margin. And then we explored which factors explain milk harvested per robot. That was the key one. And we found that the number of cows per robot and the milk yield and some other factors were the key ones. So what we did here, we included only those main factors identified in the research. It's not that every single factor that you have in the system it can be simulated and is included here. It's just the main ones. So as part of the research, we came up with these factors and these inputs as the main ones and with most impact, and actually are the ones that the farmer can manipulate: cows and milk and the daily milk yield, and the total labor. So that's the explanation of why we have only those 4 there.
So it's not only that they're the variables that have the impact, but also the ones that in a standard conversation with the farmer come up with, try to plan or determine the system. Perfect. And the figures that appear in when you start the tool in the boxes or in the graphs?
Here. Well, for example, in this, in the first one that I mentioned is the benchmarking. All the variables that appear here are the average of our database. So by default, you can see what the average farm is doing.
Perfect. Excellent. There's another question that says, "What can you please repeat what the colors mean?"
Yeah. So, for example, in this case, we have milkings per robot. So the number of milkings per robot per day. The yellow color means that 115 milkings per robot per day is achieved by the 50% of the population. And on the other hand, if you go to, let's say, 200, the color changes to green, which means that only the top 25% of the farms are achieving 200. Well, 200 is a lot here, but let's say 160. So this means that only top 25% of the farms of the whole population that of the whole data that we have achieve more than 160 milkings per robot per day. And I don't remember if I mentioned here, but this number here is the minimum achieved by in the dataset, and this is the maximum achieved in the dataset.
Okay, so it's not only it's a combination, so you can see the actual figure that in that case is 160, but also are you within the bottom 25%, within the average, let's say the middle 50, or in the top 25%?
Yeah. So it's based on those distributions that I mentioned before.
Yep. And the really important thing is that is not only theory based, it's data from real commercial farms. So almost 30 farms operating across multiple scenarios and regions and times of the year and countries over 5 years. So it's real data that gives a realistic expectation of what kind of can be achieved.
Yep. Any other question, Nico, there?
No, no more.
Continue. So this economic performance tab, what it shows is some mothers indicators, like we included here return on total assets and labor efficiency, in addition to the system performance one. And then finally, you can you get into this tab that is the system optimization. That first, what it shows here is a table. This table shows all the variables that we saw before in those gauges in a table format. So the milk harvested, cows per robot, all the variables that were simulated based on these 4 numeric inputs. So this is the current scenario, as we call it. And this table also shows a probability that is similar to those colors that the gauges show. And here, for example, in our scenario, we simulated 1,400 kilos of milk harvested. So 30 here means that only 30% of the farms achieve 1,400 kilos or more. So it's the same as the color, but you have here the probability number, the same with all the other variables. But the main thing of this tab is that you can, so you first set your current scenario, and then what you can do here is run an optimization that allows you to go from a scenario A, let's say the current scenario, to a scenario B. For example, you can set here a milk harvested target and then run that optimization. By default, here is set on a 20% plus 20% from this number, but you can here change the slider and put your own figures. but let's assume that it's at 20% from this. So you run the simulation, and it shows here an optimized scenario. That is basically what it shows is how to go from this A to B, that is 16, on average 1600 kilos. So for example, what you have to do here is increase cows per road from 67 to 69, and increase milk yield from 22 to 24, and so on. As I mentioned here, this is the probability of achieving this value. So in this case, what it shows is 1600 kilos, it's only achieved by 15% of the farms, and 69 cows per robot is only achieved by 13%, and 24 kilos only by 39%. So it shows you how to go from the situation A to B, but also how likely is to achieve that scenario or those that performance. So as I mentioned, the target is suggested by default, and the inputs for that for the simulation are also suggested by default. In this case, it's minus and plus 20% from the current scenario. So for example, if you have 22 liters per kilos per cow per day, the system looks in between 18 and 26 kilos per cow per day to simulate the scenario. So the inputs are also suggested by default and are similar to your current scenario. So to give a similar, to simulate a similar system, but you can change. For example, you can say, I want to achieve that higher milk harvested, but I cannot milk, or my limit cow production is 24 liters. So you can run again the simulation, and it won't go over 24 liters. So in this case, what it says is, well, if you want to achieve this value, you have to increase even more cows per robot, and you can maintain your production within 22, 23 liters. But for example, achieving here 71 cows per road, it is more unlikely. Only 10% of the farms are achieving this value, so it's difficult. So as I said, it gives you the path on how to achieve that value, but also how likely is to achieve it. Yeah, and you can constrain all the different inputs. You have here more detailed inputs that you can constrain. You can constrain other things that we found in the research that are relevant, like the milk flow, the timing robot. You can start playing with those things. So it's really flexible. What you can do, you can constrain, you can set a target. It's really flexible. And then what you can do is download this as a report in an Excel spreadsheet. So if you want to analyze it later, you can download it. So that's, I think, an overview. I don't know if I'm missing something else, Nico.
Maybe the tool. There's no questions that came for the time being, but I think the important thing also to highlight, Juan, is that this is kind of the world's first tool of this type. Like, most of it has been based on either assumptions or kind of more theoretical simulations. This is really backed by a large data set for the number of farms that we have. Obviously, it's not huge, but it's a robust data set that is both physical and economical, captured over multiple years on multiple farms. So it gives that scenario of the likelihood. The other thing that I think is quite cool is that when you simulate, and you can try a scenario if you want, but if it thinks it's unreasonable, it will tell you, look, achieving that, it's really not something that you can really achieve. So it gives you some indication of not only what to expect, but also how to achieve it.
Yeah. So one thing to mention also is, as I mentioned in the presentation, it uses mainly simulation that is called Monte Carlo, and is based on distributions. So here we suggest to use ranges instead of single values. You can put a single value, but the model will struggle to find a solution in such a narrow range. So it's better to set a wider range. But for example, as Nico mentioned, if you want to achieve this level, for example, with the resources that you have or similar resources to the current scenario, it will say this scenario is unlikely. Please adjust milk. You have to adjust milk harvested or milk yield in this case if you want to achieve this value. So you can
So it's like saying, I want to achieve much more milk per robot because that is linked to profitability, but I don't want to change my cow numbers, my milk production, or anything.
Yeah.
But if I don't want to change anything, it's unlikely.
It's impossible. Yeah. So what you have to do is open here a daily milk yield, but it is unlikely also to find a solution if it is too narrow the range. But for example, if you want to achieve more than 200 kilos here, it will find a solution if you open the milk yield.
So Juan, also, I think the important thing to highlight of the ranges is that when you, for example, in that case, say, look, I want to optimize for a milk harvested per robot between 1950 and 2500, the model then picks within that range kind of the most optimized or likely value. So yeah, you kind of optimize it for that range. If you want to say, look, it's anything above, I don't know, 1800, you just put 1800 as the minimum and whatever on the top.
Yeah, for example, you have here a range that goes from 19 to 2500, but the model is optimizing around to 2000 or 2000 kilos. It's because it is more likely to achieve values closer to this, to let's say 2000 than to 2500. You know, it's more unlikely to, or there are few farms that can achieve 2500 kilos. So that's why the model finds a solution within or closer to this lower limit, let's say.
Perfect. So one of the examples that I was talking to another farmer the other day is that if you're planning the system, you already know how many cows you have, you already know the daily milk yield that you have. You can play with a theoretical number of robots, but then see what is the impact of, let's say, what if I put a robot less? Or what if I want to put 50 cows more? This tool allows you to start kind of getting a better understanding of those things that before was just kind of a desktop exercise, let's say.
Yeah, and it's really, we try to, the first thing that we consider is to build something that was easy to use, as we mentioned. So as you can see here, you don't have, because we could potentially include every single indicator, every single price, milk price, feed cost, whatever, but we decided not to include. We keep it simple, and that's why it predicts based on these four, or based on few indicators, but the data and the evaluation of the model show that it's pretty accurate, and it's useful to have a rough estimate of how things change according to changing other variables, and how, if you change some physical indicators like cows per robot, or if you increase milk harvested, how that will impact profitability at the end. So that was the main idea when we developed this tool.
Yeah, and it also helps to understand what variables to look at. Like to say, okay, what is important when I'm starting to look at a robotic system? What are the variables that I need to pay attention? What are the values that seem kind of average or normal, and then help optimize that. The other tool that from the literature review that you've done is there's no tool that allows you to optimize, suggesting what are the next steps. So I don't know if you said it, but what's the difference between 1, 2, and 3 stars in there?
Yeah. So what the stars means is it ranks the variables that the farmer can easily manipulate. Cows per, in this case, cows per robot, milking frequency, and milk yield. Ranks in order of which one of the three will change more milk harvested. So, for example, if you which means that if you have to start with one of these three variables, well, start with this one, with milk yield in this case. That will be the one that will have a more impact on milk harvested and on profitability at the end. So yeah, it kinds of rank the variables. So shows you, well, let's start with this one that will have more impact, and then continue with this one, and at the end with milking frequency.
Perfect. There's a question that came through. Most of the probabilities are very low. You might look at that and think that the chances of success are very low. Are there some KPIs on which you want to achieve a decent chance of success? Example, 50%?
So
I think the question refers to most, like if you look at the current scenario, most of it are around 40%, but when you look at the optimized, the numbers go down. So yeah, a bit of a comment on that, or which KPIs should you look at that achieve roughly 50%?
Well, this probability will depend on the inputs that you set and the target that you set. For example, in this case, our target was achieving more than or almost 2,000 kilos of milk. So it's highly unlikely to achieve that target. You can achieve it, but as you mentioned here, the probabilities are really, really low. Probably if you have to set up a new target with a more reasonable value that will give you more reasonable probabilities of achieving some of these indicators or some of this performance.
So I think it's also a reflection of kind of what's your starting point, that is the current, and how big is the jump to the optimized. If you're performing at a current performance that is very low, the probabilities will be very high because most of the farms achieve more than you. Whereas, and you want to make a big jump, the probabilities will be very low because most of the farms are achieving below you. So I think part of it depends on that. The other important thing to mention is that you can, let's say you say, look, it's really risky for me thinking that I'm going to be within the top 15% of farmers that can have high number of cows. You can pull that back. You can say, look, I want to bring cow numbers down by adjusting the KPIs
you can
optimize.
Here you can play with the cows and milk, the total cows and milk, to adjust this number. You can change it here. So it's pretty flexible. You can change almost all the indicators that have impact on the system.
The important thing also to mention is that before, like we tend to assume, okay, if we have 67 cows per robot that produce, in your current scenario, 22 liters, if I put one cow more, it will be 22 liters more. And if I put two, it will be 44. And if I put three, it's 66. When in reality, we know that the more cows you put, as you've showed, it might impact milking frequency, which will impact milk yield. So it's kind of interactive in the sense that, it's not linear. You touch one thing and that has ripple effects on other variables.
Yeah. So that Monte Carlo simulation that I mentioned before is based on how every one of these indicators, or the shape of, or the distribution of every single indicator, plus the correlations or associations between all of them. So it's a pretty complex thing. So you change one thing and can affect positively or negatively another one, but all linked together. So
and we definitely think this interacts with the herd management software. Like today, the software gives you the report, let's say, of, I don't know, what's the milking frequency, but it doesn't really allow you to know if that's good or bad, or if farmers are achieving more or less. So by looking at the benchmarking tab, you can see if 2 is high or 2 is low, because you can put the figure within. If you go Juan to AMS benchmarking, and you put 2 in milking frequency, you will know kind of how do you compare with other farms. And that's the first thing that you can do with this that you cannot do with herd management software. The second one is that most of the softwares tell you kind of where you are, but don't allow you to make a change moving forward, or saying, okay, if I'm here and I want to go here, what things should I change to make that transition? And that's why I think a tool like this is really powerful, because it's kind of predictive in a sense of trying to understand that future performance.
Yeah, and as you mentioned, Nico, there are almost no tools available, and the only one of the few ones available are for confinement systems and are based on models, but theoretical models, so not based on real data. So this is robust because it's all the distributions, all the data that we presented here is based on real data collected from several farms across multiple countries, regions, and years. So I think that makes the tool robust.
Perfect. And there's data that continues to be added, which really makes it really powerful. Yeah. Well, we should also probably thank you first for your time here today, Juan. Obviously, you've been very busy the last 3+ years developing all this. And when you say we developed, it's really you developed. So all the kudos goes to you, doesn't go to a we that is collective, goes to a you. So well done there. But also to the farmers that have contributed all the data over these years. Like, it wouldn't be possible without them. So excellent. I don't know if there's any other question. Otherwise, I'll probably wrap up. I won't keep you for long, but one second. Perfect. So just to continue on that, a lot of the information that Juan presented today is included within what we call the Milking Edge online AMS information modules. So as part of Milking Edge, we developed a series of information modules that are available online in that link that you can see on the screen. And you can jump online, they're free. You can do one or more at your own pace. There's 8 modules that cover different key farm management areas. So you can jump online, do one or more at your own pace in the order that you want, and they cover different aspects. But the ones that are probably relevant to the topic that we covered today are one that is called Assessing AMS Performance, and one that is called Economic Performance of AMS. So jump online and explore those. And those also support the training module, where we take people through the 8 modules themselves. If you want to follow our initiatives, we've just made a fresh look and feel to our DPI Dairy website. So jump online and you can have a look at all the kind of tools and resources that we produce. We produce a quarterly newsletter that focuses a lot on areas of precision farming and robotic milking. So the last one went out last week, but you can subscribe or you can access previous editions on our website. And we also have a Facebook page, New South Wales DPI Dairy. So please jump on board of any of these for more information. So with that, Juan, I want to thank you once again for your time and your willingness to share your insights and your journey with us today on this great tool. I know it can be a bit overwhelming if it's the first time you have a look at it, but we thought it was really important to show you what we have developed and what the tool could do. And if you want more, when we share the recording of this webinar, we'll share the link to the tool, which is also on our website. And you can access and play, and there's a tutorial, and Juan is always available if you need any information about it. So with that, thank you very much. I hope to see you again in our next webinar. And if you need more information, please go to the New South Wales DPI Dairy website. Thank you very much. Stay safe, stay well. Bye-bye.